Yes, good morning, student. So, last class we have started with the midpoint line drawing algorithm. Okay, and we have discussed how the midpoint algorithm works. So, we have seen a property of your circle, that is eight-way symmetry property, because of which you need not calculate the coordinates of each and every point. Just the coordinate of one octant is enough. Coordinate of one octant is enough in order to calculate the coordinates of all 7 octant in your circle, right? And then we have seen that in midpoint algorithm, your x value will be incremented at every iteration, whereas y you are going to decide whether to decrement or you have to go ahead with the same value, right? So based on that, we have did the derivation for that, and then we have solved two example for radius 8 and one more is for radius 10. Okay, this one I told you to verify. I hope you verified your answer. Did everyone get the same answer?
Yeah.
Okay. So in today's class, we are going to discuss Bressenham line circle drawing algorithm. Why we are going for Bressenham is because in midpoint line drawing algorithm we have seen that you end up with a floating point value, right? So here we have seen that it is 5 by 4 minus r, which will give us the floating point value. But just to ensure that it is easy to perform calculation, we have considered it as 1 minus 4. But the actual thing is it will give you floating value and you have to do all the calculation with respect to floating value, which is time consuming, right? So hence to avoid that, we'll go for next algorithm, that is Bressenham circle drawing algorithm. Similar to line drawing algorithm, your Bressenham algorithm helps to overcome the computational time consuming due to computational complexity. We are going to avoid using Bressenham circle drawing algorithm. So let's just see how this algorithm works. Okay, before I start, okay, we already know that your circle follows eight-way symmetry, right? And we are going to start with the first symmetry, which is at angle 90 degree, right? First octant, which starts at angle 90 degree, and you are going to calculate till you reach, what is this degree? This is 45 degree. Till you reach 45 degree, you are going to calculate the value of every coordinates, and here you are going to decide either you will go ahead with xk plus 1 yk, right? Or we are going to consider xk plus 1 yk minus 1. So the algorithm is mainly to decide this, correct? So with respect to this, in circle midpoint algorithm, we considered the difference and between those two, and we took the average and then we started the calculation. Whereas here, a little bit different it is. So let's say this is our center point, okay, and sorry. If my center is 0, 0, so that's our assumption. And let's say our distance between the center and your point A, okay, and your point A. Distance between the center and your point A is dA, and distance between the center and your point B, let's say our point B is somewhere here, okay, distance between the center and your point B is dB, fine. And your circle will be something like this. Your point B is inside the boundary, point A is outside the boundary, okay? So something like this. This is dA. So dA is the distance between the center and the point A. dB is the distance between the center and the point B. So this is at yk, and this is at yk minus 1. And similarly, this is xk, right? And this is xk plus 1. Fine? Okay, so now we have to make the
Ma'am, are
decision.
you writing anything right now?
Yeah,
Are you writing anything right now? Because we can't see what's being written.
you are not able to see anything because
Like, I'm able to see the slides as in what was already written last class, but if you're writing right now, I can't see that.
is it same for everyone?
Okay, now I can see.
Yes,
No,
ma'am.
actually, now can you see this?
Yes, ma'am.
What you can see, I have written 90 degree and this is a 45 degree, and then have drawn one line saying it's a distance between 0 and A. Can you see
Yeah, I
those
see
things?
that.
Yeah, okay,
Yes.
great. So now this is our center point. This is a center point which is 0 and 0, and this is 2 point which we have to decide whether you have to go with A or B. And A, it is at a distance dA, and B at a distance dB from your center A. And let's say from your boundary to your point A, okay, from your boundary to your point A, the distance is delta A. Similarly, from your boundary to your point B, the distance is delta B. Okay. So what is dA? dA is the distance between center and point A. Fine. Similarly, dB is distance between center and point B. Delta A, distance between circle boundary and point A. And delta B is the distance between circle boundary and point B. I hope this is clear. So we can say that your dA is nothing but R plus delta A. Is it correct? What is R? R is the radius of the circle from your center point to the boundary. Okay, the distance is R, and delta A is from the boundary to the point A. Similarly, you can write R is equal to dB plus delta B, right? Because dB is a point inside the boundary. Hence, your R will be equal to dB, that is the distance between the center and the point B, plus delta B, which delta B is the distance between the point B and the circle boundary. So, this is the equation. So, what we can rewrite it as in terms of dB. If you want to rewrite it, that will be dB is equal to R minus delta B. Is it clear till here? Is it clear? If you are not able to understand, do ask. Is it okay? Shall I continue? Okay.
I'm just noting it down.
Yeah. So our A is the point xk plus 1 yk. Okay, this actually it should be in a same line. Actually, I've shown it in a two different this one. So this I have done a mistake. So delta A and your point B, they are actually like this. Okay, I have done slight mistake over there. Initially you are at this point. Okay, now you have to make a decision whether you have to go with this point or this point. So at this location, initial point it is xk, and next point it is xk plus 1. So just assume that these 2 points are in the same line. Okay, it doesn't look like in this diagram, but these 2 points are in a same line. This is our point A, this is our point B. Okay, just do little modification to this diagram wherein you have these 2 points in a same line, and this is our yk, and at this point it will be yk minus 1. So I'll just rewrite it. Hmm. Is it okay? I hope this is clear. So just avoid this. Fine. So we have 2 points, that is A, which is at xk plus 1 yk, and B, which is at xk plus 1 yk minus 1. So these are the coordinates. So now you have to calculate a distance dA. How we can calculate distance dA, which is the distance between your point and the center of the circle. So let's make use of Euclidean distance algorithm. So that is root of xk plus 1 minus 0 whole square plus yk minus 0 whole square, right? In Euclidean distance, how we are going to calculate? It is root of x2 minus x1 whole square plus y2 minus y1 whole square. In our case, your x1, y1 is 0, 0 because we are dealing with origin, and x2, y2 is xk plus 1 and yk. So here we'll get root of xk plus 1 whole square plus yk square. Similarly, calculate dB. Again, Euclidean algorithm is used. Xk plus 1 minus 0 whole square plus yk minus 1 minus 0 whole square. So you will end up with xk plus 1 whole square plus yk minus 1 whole square. Fine. Okay, is it clear? Is it clear? Can I change the slide?
1 minute.
Yeah. Let me know once it's done.
Now I'm done.
Yeah, okay. If everyone is done, I'll go to next slide. Uh-oh. Just a minute. I'll just add few empty slides. I hope it will be enough. Okay. So now delta A, which is the distance between your point and the circle boundary, okay, is given by dA minus R. Correct? The delta A is given by dA minus R, and your delta B is given by dB minus R. So we are going to consider delta A naught is equal to dA square. We are going to square terms here. Delta B is square of dB square R square. Why we are doing this? Because we want to avoid square root. Because we have square root in a previous, while calculating the distance, we have made use of square root, right? Just to avoid square root, we are just going to do a square of these terms. Fine, because dA and dB we have represented in terms of square root. I want to avoid this, and we want to deal with delta A and delta B because you want to decide which one is near to the circle boundary, right? So delta A is dA minus R, where dA is the distance between the center and the point, and R is your radius. And as you know, your A is outside the boundary, hence dA minus R will give you positive value. And in this case, delta B is equal to dB minus R, where dB is the distance between the center and the point B. And we have seen that point B is inside the boundary, and R is the radius of a circle, and this will give you negative value because your dB is inside the boundary, and this will give us positive value. So now based on this, we are going to calculate our decision parameter, equation for decision parameter. Our decision parameter, we are representing it as P, will be equal to delta A dash, okay, or delta A naught plus, sorry, delta A naught plus delta B naught. This is a positive and this is a negative value. So we are doing these two addition in order to calculate your decision parameter. So what this will give, if you end up with P as a positive value, okay, what is the condition in order to get positive value? If your delta A is greater than delta B, okay, then we are choosing pixel A. Sorry, so I'll just write pixel A, then we'll choose pixel A. Choose pixel A, and if you get a negative value, which is when your delta A is less than delta B, at the distance of your delta the distance of your delta A is less than the delta B, then you have to select B. Okay, so these are the conditions based on which you are going to select your pixel. So P is our decision parameter. You are going to calculate delta A dash plus delta B dash, or delta A naught plus delta B naught, and see what's the value of P. If you get a positive value, and which means your delta A is greater than delta B, okay, then you are choosing the pixel A. And if it is delta, if it's a negative value, then delta A is less than delta B, and we are choosing the pixel B. So let's try to replace your delta A and delta B with delta A naught and delta B naught with dA square minus R square dB square minus R square. Okay, so we'll just rewrite our equation B. I think I'll write it here is equal to delta A naught plus delta B naught. And what is delta A naught plus B naught? It is dA square minus R square plus dB square minus R square. Okay, and now represent your dA in terms of your x and y. So that will be xk plus 1 whole square plus yk square minus r square. Similarly, your dB will be xk plus 1 whole square plus yk minus 1 whole square minus r square. So if we combine those two terms, we will get 2 into xk plus 1 whole square, this is 2, right? Plus, I'll write yk minus 1 whole square, yk minus 1 whole square plus yk square, this minus r square, that will be minus 2 r square. So this is our pk. Let's say this as a equation 1. Similarly, the decision parameter of the next term or the next iteration will be pk plus 1 is equal to, just replace xk with xk plus 1. So these are our new term. Let's call it as equation 2. So next step is we have to do equation 2 minus 1. So you will get the difference in decision parameter. Pk plus 1 minus pk is equal to 2 into xk plus 1 plus 1 whole square minus 2 into xk plus 1 whole square plus, this is yk plus 1 minus 1 whole square minus yk minus 1 whole square plus yk plus 1 whole square minus yk square minus 2r square plus 2r square. So this is a term after subtracting pk plus 1 minus pk, right? So now you can put xk plus 1, because we know that in circle at every iteration your x value will be incremented. So we can directly write xk plus 1 as xk plus 1. Okay, so uh, just rewrite the equation and put xk plus 1 as xk plus 1. So can I just write a simplified term directly? You can do the simplification from your end. I'll just directly write the final answer. So pk plus 1 will be equal to pk plus 4xk plus 2 into yk plus 1 whole square minus yk square um, minus 2 into yk plus 1 minus y plus 6. So this is a term for pk plus 1. Okay, you can just write it down till here. Okay, I have worked this thing. I have written in a reverse order. This should be B, right? No one pointed out, right? Because when delta A is greater than delta P, which means your A is far away from your boundary, okay, compared to delta P. Hence, you have to select pixel P. And when it is less, you will obviously select pixel A. I wrote in a reverse order. Just make sure you update this. Is it done? So what we did so far, we have represented the distance between the point and the circle and the center of the circle as dA, and the distance between the boundary and the point as delta A, and similarly dB and delta P. And then we are calculating the decision parameter in terms of delta A naught and delta B naught, because we want to avoid the square root, hence we did the square. And then we know that the P is positive if delta A is greater than delta B, which means if your delta A, the distance between your point A and the boundary, is greater than the distance between the point B and the boundary, which means A is far away from the boundary, you are going to select B. And if A is near to the boundary compared to delta B, then we are going to select pixel A. Then you are calculating the decision parameter, which is the addition of delta A naught plus delta B naught. Just represent delta A and delta B in terms of dA, right? And then represent in terms of xy, which is we already calculated over here, right, in terms of this. So we are going to represent it with that. And then you have your pk, which is equal to this equation. Then calculate the next decision parameter, which is p of k plus 1, wherein you are going to replace k with k plus 1. And we already know that in a circle you are going to increment your x value at every iteration. Hence, replace x of k plus 1 with x of k plus 1. So this is our final equation for decision parameter p of k plus 1. So next, if our p of k is less than 0, so if our p of k is less than 0, which means we are going to select point A, which means your yk plus 1 will be equal to yk. And you're selecting your point A, so yk plus 1, okay, the next iteration as well, it will be equal to yk. If you're selecting B, it will be yk minus 1, whereas now we are selecting A, hence it is equal to yk. So now rewrite our equation and replace yk plus 1 with yk. So next our pk plus 1 will be, in a pk plus 1 you are going to replace yk plus 1 with yk. So you'll end up with pk plus 4xk plus 6. So this is our pk plus 1. Similarly, if you are calculating for pk which is greater than 0, where we are selecting point B and your yk plus 1 is equal to yk minus 1. So here you'll have your p. I'm directly writing the final value, okay? You can put the term and do the simplification. Or do you want me to do the simplification? Just in pk plus 1 equation, you have to replace your yk plus 1 with yk minus 1. That will be what? Pk, I'm just going to do this, plus 4xk plus 2 into yk minus 1 whole square minus yk square minus 2 into yk minus 1 minus yk plus 6. So if you put that in your equation, you'll end up with this. Then just simplify it, plus just take 2 here. Just make use of a square plus b square minus 2ab, that equation. You will get yk square plus 1 minus 2 yk minus yk square. And here yk will get cancelled, it will be minus 1. So minus 1 minus 2, that will be plus 2 plus 6. So we'll end up with pk plus 4xk. Here this term will get cancelled. So you'll get 4yk plus, okay, 6, 7, 8, 9, 10, 2 ones are 2, right, 10. So this is what you get for pk greater than 0. So now you got for pk less than 0 and pk greater than 0. So next step is to calculate initial decision parameter. Fine. So initial decision parameter is what? X naught, Y naught. We are going to consider it as 0 and R, right? We are going to start from the first octant. So hence, so we have a pk equation as pk is equal to 2 into xk plus 1 whole square plus yk minus 1 whole square plus yk square minus 2r square. So this is the equation we got for pk, right? So just substitute your x and y with 0 and r. We'll get 2 into 0 plus 1 whole square. So this will be r minus 1 whole square plus r square minus 2 r square. So that will be equal to 3 minus 2 r. You can see here we don't have any factor over here, so you'll always end up with the integer value, right? So we have calculated the decision parameter for two conditions, that is less than and greater than 0. Then we calculated the initial decision parameter for the first octant, which starts at 0, r. You can just take down this, and if you have any doubt, you can ask.
So
Is it done? Can I go to next slide? Okay.
Yes, ma'am.
Yeah. I'll just, because we did lots of derivation, I'll just write the algorithm in short here. Okay. So this is
you didn't show the coded algorithm for the previous circle drawing algorithm.
no, I showed it for initial few, right? So based on that, I think you can write it, no? So all concepts are like algorithm we are going to write based on this itself, right?
Yeah.
You just refer to line drawing algorithm, and you can just do little modification to get it. Because concepts wise, I have done it. Okay, so this one, first what we did is, we are going to determine the radius r of a circle, right? We need r. Only after knowing r, you can proceed further. So in midpoint line drawing algorithm also, first we are going to see r. Then you are going to make an assumption that the center of the circle lies at origin. This same rules applies to your midpoint line circle drawing algorithm as well. Next, what we do, plot the first fixed pixel of the first octant, right? Even this is similar to your midpoint. And our first octant has a coordinate 0, r, where x is 0 and y is r. So once that is done, we are going to calculate. See, based on this, you can write for midpoint circle drawing algorithm. Just the flow will remain same. Little bit modification we have to do. You will get the algorithm for that. So next we are going to calculate initial decision parameter. Right? And what is the equation for that? 3 minus 2r. Then we are going to run a loop. Your x is less than or equal to y. Till this condition is satisfied, you are going to execute this. If p of k is less than 0, then your p of k plus 1, which we just calculated in a previous slide, will be p of k plus 4xk plus 6. And you are going to increment your x. Whereas y, it will remain same, no change to y. Else, if p of k is greater than or equal to 0, then so what will be our p of k plus 1? We just did the derivation, right? So it is pk plus, I'll just take 4 common, xk minus yk plus 10, and xk plus 1 is equal to xk plus 1, and your yk plus 1 is equal to yk minus 1. You are going to decrement your y. So next is whatever point you are getting, you are going to plot it. Okay, you have to consider a coordinate system and you have to plot the values obtained using this algorithm. So once this is done, once you are done with the loop, which means you have calculated all the coordinates of first octant, next what you are supposed to do? See, in midpoint algorithm, only this will change. All other things will remain same, right? Just see how we did the derivation for that. Replace it with that value. So here, 7th point is you are going to determine and plot symmetric points in other octant. So we have calculated the points in other octant based on the points which have calculated from your first octant. So we have done that for your midpoint circle drawing algorithm. Same thing applies here. Okay. So this is based on the assumption that your center point is 0, 0, right? Let's say if your center point is not 0, 0, if it is xc and yc, okay? If this is my circle center, what you have to do? Okay, using this equation, you are going to calculate what? Xk plus 1. At every iteration, you are going to calculate xk plus 1 and yk plus 1, right? Using this algorithm, you are going to calculate it, xk plus 1, yk plus 1. And if the center is other than 0, 0, then what you have to do? You have to consider, after calculating this, you have to do this changes. Xk plus 1 plus c and yk plus 1 plus c. These changes need to be done. So let's consider one example. If xc and yc is 2, 3, okay, and xk plus 1, yk plus 1 is 10, minus 9. If this is the case, then xk plus 1 plus xc, yk plus 1 plus yc will be equal to 12, minus 6. So you can get the plot like this. But for algorithm, we are assuming that the center point is 0, 0. But if the center point is other than 0, this is how you can get the points. Just you have to add xc and yc. Okay, just state on this algorithm. Then we'll try to solve one problem based on this. Okay, so once you are done with this algorithm, just try to solve for radius r using Bresenham algorithm. Okay, radius r. We just need to give radius, right? So using Bresenham algorithm, try to solve a problem where you have radius is equal to 4. I have given a small value. You can plot a circle which has a radius 4 unit and make use of Bresenham circle drawing algorithm. Yes, did you write this algorithm? Can I go to next slide? Let's try to solve it together.
Yes, ma'am.
Yeah. So what is given? The radius is given and we have asked you to calculate all
Minus
the
5.
coordinates using the algorithm. So what we have x, y and a p. So this is our first thing, right? So what's our first coordinate? Because the radius is 4 and we have to start with our first octant. So 0, 4. What is the initial decision parameter? We don't know, so let's calculate. So x and y was 0, 4. Initial parameters t naught, which is equal to 3 minus 2r. So we know r, just substitute r, which is 3 minus 2 into 4. You will end up with minus 5, correct? So let's write minus 5. So first iteration, your p value is less than 0. When your p value is less than 0, what will be your pk plus 1? It is pk plus 4xk plus 6, right? It's pk plus 4xk plus 6. Substitute values. Pk minus 5, xk is 0 plus 6. So we get 1. You have to increment x. So x is 1. Y we are going to retain the same value. We'll get 1, 4 and 1. Second iteration, 1 greater than 0, pk plus 1 will be equal to pk plus 4 into xk minus yk plus 10. We have here, right? Pk plus 1 equal to pk plus 4 into xk minus yk plus 10. Substitute values. It's 1 plus 4 into xk value is 1. Yk is 4 plus 10. 12 plus 10, which is equal to minus 1. K plus 1 is, you are going to increment x, so hence it is 2. And yk plus 1, you are going to decrement your y, hence it is 3. So we'll write here 2, 3 and minus 1. So third iteration, again minus 1, which is less than 0. So for pk plus 1, we'll make use of this equation. Minus 4 plus 4 into 2, which is xk, plus 6. We'll get 13. And xk plus 1, we are just going to increment 3. So y, no change. So 3, 3 and 13. So we are going to stop here because now your x has equal to y. So we can stop at this moment. So let's just write down all coordinates. At q1 you have 0, 4, 1, 4, 2, 3, 3, 3. This is for first octet. Second octet we have to just write in a opposite order, right? So 3, 3 it's the same value, so we can ignore it. We'll go with this 2, 3. We are going to write it as 3, 2, 1, 4. Write as 4, 1, 0, 4 is 4, 0. This is our value of coordinates in first quadrant. Similarly, go for Q2. Q2 is minus x, y. Then you can similarly write for Q3, which is minus x, minus y. Then go for Q4, which is x, comma, minus y. Just rewrite it. Okay, this 0, 4 will remain same. Right? Because that's our first point. So here, minus 1, 4, minus 2, 3, minus 3, 3, minus 3, 2, and minus 4, 0. In this case, both terms are minus. Minus 3, minus 3, minus 3, minus 3, minus 2, minus 4, 0. And in this case, your y is negative. Okay, is it clear? Any doubt so far? So we have done almost 4 algorithm, midpoint and Bressenham line drawing algorithm, midpoint and Bressenham circle drawing algorithm. And we have solved few problems based on that. Any doubt? Okay. Can I start with the next topic then? Can I change the slide?
1 minute, ma'am.
Yeah, you can take it down, no issue. So next I'll be starting with midpoint ellipse drawing algorithm.
Done, ma'am.
Yeah. So next what we are discussing is midpoint ellipse drawing algorithm. So as you know, your ellipse is nothing but it is another form of your circle, right? It is again a circle but in another form. So it is nothing but elongated circle. At one direction it is elongated. Okay. So here equation of the ellipse at the center is given by, okay, before that, so we know that our circle equation is what? X square plus y square is equal to r square, right? So before writing that, we can write your equation of the circle as this as well: x square by a square, y square by b square is equal to 1. This is also equation of your circle, where a and b is what? It is the uh, it's actually a radius. If this is my circle, then while writing equation of a circle, this term will be a and this term will be b. Correct? So, and we know that your a and b is what? It is r. So it will become r square plus y square r square equal to 1. Hence, you are writing your equation of a circle as x square plus y square is equal to r square. I hope you know this, right? So we are using the same equation of a circle for your ellipse. So how your ellipse will look like? It is something like this. Okay. Fine, it will look something like this. It's not a circle. So here this point is your A and this point is your B. So same equation holds, but instead of R and R, let's write it as RY because they are different. This is RY and this is RX, and this is our X coordinate and this is our Y coordinate. Okay. In your ellipse, you will have two axes, right? First is major axis, which is nothing but a longer axis, which is major axis in this case, your Rx, your X coordinate is a major axis. It's a longer axis. so that you can rewrite it as 2 into okay, A I have wrote for X, no, sorry, you can just, today I am doing this. I wrote A for X and B for Y, so just write it B here and A here. Okay. So this will be 2A, or you can say 2 into Rx. Similarly, we have minor axis or shorter axis, which is 2B. In some book they have written in terms of A and B. In few books they have written in terms of Rx and Ry. Okay. Then half of it, if I'm considering only half of your ellipse, then the semi-major axis. This is just a background I'm discussing before we actually start with the derivation. So semi-major axis will be equal to A or Rx. Similarly, semi-minor axis is equal to B, that is Ry. So let's rewrite this equation. I'll write it over here. It is x square b square. So this b I'll take it at this side, plus y square a square divided by a square b square is equal to 1. Okay. Then I'll just rewrite this term, b square x square plus a square y square is equal to a square b square. B square x square. This is the equation of your ellipse. A square y square minus a square b square is equal to 0. So let's just write in terms of Rx and Ry. Y square x square plus Rx square y square minus Rx square Ry square is equal to 0. So this is the equation. Okay. So if this term, okay, if a point in equation 1 okay, if it is equal to 0, if the point in equation 1, if it is equal to 0, which means your point lies on ellipse, right? There are three different conditions, and if it is less than 0, which means it is inside your ellipse. Similar to circle. In circle also we had same, no, inside the boundary, outside boundary, on the boundary. Oops. And then if it is greater than 0, which is outside ellipse. Fine. And one more thing, in circle we have mentioned that it satisfies 8-way symmetry property. Whether it satisfies 8-way symmetry property in ellipse?
No, it's only 4-way symmetry this time.
Yes, it is 4-way symmetry this time, because in one quadrant, okay, it is not equally distributed. Like after this, it's not the coordinates are not same as this, because your x value change, your y value vary. You have to decide whether you have to consider how your x value is changing, whether it is changing in an increment value or not. So that decision need to be done. Whereas when you go for circle, it will always change in a increment fashion, right? And your y you have to decide. So that thing varies when you come from circle to ellipse. And your x is elongated one here. You can see that it's a major axis, that hence it is known as a major axis, and this is your y. So they vary in the distance as well. So hence you can't just calculate the coordinate of one octant and calculate the rest. Instead, what you can do is you have to calculate the coordinate of two octant, or you can say you have to calculate the coordinate of one complete quadrant, so that you can get the coordinates of remaining three quadrants. So will be calculating the coordinate of complete quadrant, and in order to calculate that, you will have a different set of equation for first octant and second octant, because the region are not same, they are different. Okay, so accordingly you will be doing the derivation for two different region in this case. So before that, add few more slides. Okay. So in Bresenham, it's not Bresenham, sorry. Okay. So in your ellipse, each quadrant is divided into two different regions. Okay, it satisfies eight-way symmetry. So I'll start from there. Oh, sorry, four-way symmetry. And each quadrant is divided into two different regions. Hence, it differs in the way we plot the coordinates. Right? So it will be something like this. This will be elongated. Okay. This is our region 1. This is our region 2. And what kind of a decision will be in region 1? If initial point is this, we have to make a decision whether it is in a same line or in a different line. Right? In region 1, your x will be incrementing in every iteration, whereas your y will be decremented, and you have to make a decision whether you have to go ahead with the previous or the next value, similar to circle. Okay, so you are going to make a decision with respect to this two. Whereas in region 2, this is our initial point. Okay, and here your y will be decremented at every iteration. Okay, initially it is here and next it will be decremented. But whereas your x, you have to make a decision, like whether you have to go with this or you have to go with the next value. You are going to make a decision whether x need to be incremented or you have to consider the previous value. Okay. So the way we are proceeding with respect to each region varies. Here you are calculating whether you have to select yk or yk minus 1. Whereas in region 2 you want to decide whether you have to go ahead with xk or xk plus 1. So let's write with respect to each region. In region 1, okay, so first thing is its start point is 0 comma ry. And your slope. So in region 1, the slope of your ellipse will be, the slope of your curve will be less than minus 1 in this region. And here, take unit step in positive for x. Like x will be incremented. Or I can just write xk plus 1 equal to xk plus 1, right? X will be incremented till you reach the boundary between two regions. That I have to write it here. Till the boundary between the two regions is reached. Okay. And what about y? You are going to make a decision. Yk plus 1 is equal to yk or yk minus 1. So this is for region 1. Similarly, for region 2, your slope of curve is greater than minus 1. So at the center point here the slope is equal to minus 1, whereas here it is less than minus 1. Here the slope is greater than minus 1. The slope is greater than minus 1 and your y of k plus 1 is decremented at every iteration till the end of the quadrant. Okay. And we are going to make a decision with respect to this one, that whether we have to go with xk or xk plus 1. Okay, so this is a background. So we will be having four-way symmetry here, and we have two different regions with a different slope. Region 1 has a slope less than minus 1 and region 2 has greater than minus 1, and in region 1 your x value will be incremented at every iteration till you reach the boundary of region 2, and your y value you want to make a decision whether you need to be decremented or continue with the same value. In region 2, slope is greater than minus 1 and y value will be decremented at each iteration, and x value you are going to make a decision whether you need to increment it or continue with the same value. So based on this, we are going to do the derivation for region 1 and region 2. separately. Okay, so in today's class, let's continue with the derivation of region 1. Okay, is it done? Did you take it down? Can I go to next slide? Can I go to next slide?
Yes, ma'am.
Yeah. As we are going for midpoint ellipse drawing algorithm, this is for region 1. Okay, so we have 2 points, xk plus 1 y and xk plus 1 yk minus 1, because we are going to do the decision with respect to y, right? And hence, because you are going for a midpoint line drawing algorithm, just take an average xk plus 1 plus xk plus 1 divided by 2, which is nothing but xk plus 1. Similarly, for y you do it yk plus yk minus 1 divided by 2, which is equal to yk minus 1 by 2. This is our midpoint. It is similar to our midpoint circle drawing algorithm. And you know the equation for your ellipses, we just calculated in the previous slides, ry square x square plus rx square y square minus rx square ry square. Okay, so this is an equation of our ellipse. So just replace your x and y with the midpoint value. So x value you are going to replace with xk plus 1 and y value you are going to replace with yk minus 1 by 2. Okay, let's call this as P1K. This is our decision parameter P1K, because we have to calculate region 1, region 2. So let's say it as P1K. This is our equation 1. Okay, so next we want to write next iteration. Okay, next iteration decision parameter, that is P1 K plus 1. So how we can write it? We have to replace K with K plus 1. And you know that in region 1, your x value, that is x of k plus 1, is incremented always, right? R1. Hence, you are going to replace x of k plus 1 with xk plus 1. And the decision is with respect to your y term. Right? So here I'll be making use of a plus b whole square, we'll make use of the equation, that is a plus b whole square is equal to a square plus b square plus 2ab. Similarly, a minus b whole square equal to a square plus b square minus 2ab. So that equation you can make use of, and you are going to simplify your terms. Okay, I'll be writing the final term here. Replace this in terms of that. This will be your a term and this will be your b. This is your a term, this is your b term. Okay, so just simplify it. I'll be writing directly the final simplified value. that is ry square into 2 into, you can just verify it, try to do the simplification on your end, plus 1 plus rx square yk plus 1 whole square minus yk square minus yk plus 1 plus yk. So this you will be getting for p1 of k plus 1 minus p1 of k. When you do this, you will be getting with this equation. Okay. So this term is what? X of k plus 1. And y of k plus 1 is, it can be yk or it can be yk minus 1. Fine. Okay, did you take down till here?
Not yet. I'm still on the last line.
Okay. It is similar to how we did the derivation for all other algorithms. Okay. So in this equation later we are going to do it for two different conditions, right? Pk less than 0 and pk greater than 0. So those two conditions we have to consider and substitute the value of your y and rewrite the equation. So this is, that will give us your p1 value for greater than and equal to 0 and less than 0. Can I go to next slide? So maybe in today's class, I'll just finish your region 1 derivation. Region 2 we'll see in next class. Can I go to next slide?
Yes, ma'am.
Yeah. So here, when your pk value is less than 0, we know that when pk value is less than 0, your yk plus 1 is equal to yk. Okay, so this condition is there. So based on that, so based on this, your pk plus 1. So just substitute in our previous equation. So pk plus 1 is equal to pk plus ry square 2 into xk plus 1 plus 1, right? So that will give you p1k plus ry square to k plus 1 plus ry square. Okay, so this is the equation when your pk is less than 0. Similarly, when your pk is greater than or equal to 0, your yk plus 1 is equal to yk minus 1. So just make use of the same equation. Sorry, I have to write here p1. p1 k plus 1 minus, minus p1 of k. So when you do that, you had 2 into xk plus 1 ry square plus ry square plus r x square yk minus 1 whole square minus yk square minus yk minus 1 plus yk. Okay, so just to rewrite it, plus 1 is equal to p1k plus 2 into xk plus 1 ry square plus ry square r x square rx square, and this I'm using a minus b whole square is equal to a square plus b square minus 2ab, that equation. Okay, plus 1 minus 2 yk. Similarly, just open this bracket, this yk square minus yk, this will become plus 1, okay, and plus yk. Let's see if we can remove some terms. We can remove yk, yk, yk square, yk square. Okay. So next, p1 of k plus 1 will be equal to p1 of k plus 2 into x of k plus 1 into ry square plus ry square minus 2 into 2 into yk. This is minus 2 into yk rx square. Right? So this is minus 2 into yk, and this is 1 plus 1 is 2. Okay, so you are taking that 2 common. So that will be 2 into yk minus 1. So I'll just write it here, plus 1. Understood how I did that? So here you have minus 2 into yk plus 2. Plus 2, remaining term, right? So what we did, we are taking minus 2 common. So once you take minus 2 common, what you will get? Yk minus 1. And what is yk minus 1? Yk minus 1 is y of k plus 1. Okay. So hence we are writing y of k plus 1 here. Okay. Right. So this is the equation when it is greater than 0. And this is equation when it is less than 0. So based on this, your initial parameter you need to calculate. Sorry, I'm taking more time because halfway if I finish, it will be difficult to start over on Saturday. So initial decision parameter will be, we have to put x value as 0 and y value as ry in p1 of k. We already calculated p1 of k, right? So p1 of k was ry square xk plus 1 whole square plus rx square into yk minus 1 by 2 whole square minus rx square ry square. So this equation we already have. Put x value as 0 and y value as ry. So final value what you get, that is p1 of 0 is equal to ry square plus rx square by 4 minus rx square. So this is your initial parameter. So with respect to region 1, we have calculated the decision parameter P1 of k, and the next decision parameter, that is P1 of k plus 1. And then we did the subtraction, that is P1 of k plus 1 minus Pk. We got an equation, and on that equation we are going to consider two different conditions. First condition, when your Pk is less than 0, we know yk plus 1 is yk. So substitute yk plus 1 with yk in a previous equation. We got this. That is P1 of k plus 1 equal to P1 of k plus ry square into 2 into xk plus 1 plus ry square. Then you go for second condition, which is pk is greater than or equal to 0, and your yk plus 1 is equal to yk minus 1. So substitute that, we did a derivation, okay, and the final value what we got is p1 of k plus 1 is equal to p1 of k plus 2 into xk plus 1 ry square plus ry square minus 2 into yk plus 1 rk square. Then we calculated the initial parameter for the values, that is 0 and ry. So this is a initial parameter value. Okay, so we are done with region 1. So next class I'll be starting with region 2, and then we'll try to solve few numericals based on this.
Ma'am, but here
Yeah.
you put r x square by 4, right?
Yeah, that is after simplification. Here you have a minus b whole square. So what you have to do is a square
No,
plus b
but
square minus 2ab.
are the decision parameters allowed to be in decimal value?
That is the problem of midpoint. No, you will always end up with a floating point value.
Yeah, but
So
this
even in
is
our circle drawing algorithm, our midpoint we ended up with this floating point value. So here
yeah, but
also
we
same problem is there.
just but we disregarded that when we got 5 by 4 minus r.
Yeah,
We
we
instead took
disregarded
it as
only
1
with
minus
respect to
r.
numericals. We will disregard, but the actual thing it will still be a floating point. If you consider the algorithm, it will consider the floating value. But just for simplification purpose, while solving numericals, we have considered it as one in circle drawing algorithm.
Okay,
Okay, but the
we're not
actual
doing
thing
that
is it
here.
still go ahead with the floating values.
No, we're not doing that here.
Yeah. Oh, here we are doing, but now I'm just doing the derivation I have to do for region 1 and region 2. So while doing the numericals, I'll consider the values accordingly. Okay, but the actual thing is we have to consider floating value, but it becomes difficult while solving problems if you consider floating value. Hence, we are assuming it to be numerical, but actual thing is it is still a float. Okay. So I'll just save this. So next class, I'll start with region 2. We'll do the derivation of region 2 and solve few problems based on that. I'll stop recording now. See, next week you have your assignment. Okay, I think time